hopefully you can hear me well. My name is Mikhail Alexandrov, and this video is done for MHF4U at the date of 5th December 2020. So let's have a look. We're going to have a word problem, and we're going to solve it using logarithms. That's a complicated word, sorry if I pronounce it not really right. Let's first of all read the question. Light intensity behaves similarly to sound intensity. A large aquarium in a science center holds various fish and plants. Most of the plants require a light intensity of 4.2 units for strong growth. Light intensity I passing through the water can be modeled by I is equal to 10 in the power of 1 minus 0.13 multiplied by x, where x is the depth of the water in meters. First of all, we're going to highlight key terms. Well, key terms like the main points of the question, what actually we're going to really need to solve the math problem. So, and we've got two questions. One of them is use the equation and the concept of logarithm to find the depth at which the plants will receive the appropriate light. The second one is how many times less intense is the light received by the plants if they were to be placed in water 5 meters deep. So first of all, we need to identify the variables, and as you can see, hopefully I'm not sure actually that you can see my my mouse, but I is light intensity in units, and we're going to use units in brackets when we're going to solve like the problem, and x depth of the water in meters, and that's going to be m for meters. So let's deal with the first question, and we're going to first of all write down the equation. And since the needed light needed light intensity is equal to 4.2 units, when we may find x placing 4.2 units at the place of I, so we're going to have an equation, and we actually may go for x. But before that, this is the graph. This is just the basic graph. So as you can see, the equation right here in the middle, and this is how the graph is going to look like for this equation. So we may see the change for light intensity depends on the meters under the water. So here x-axis is going to be like x, and that's going to be counted in meters, and y-axis is going to be labeled as I, and it is going to be counted in units. And as you can see, further we go down, less light intensity is there. So let's go here. We have got our equation, like a nice picture right here. So first of all, we're going to use double log, and we may express the following equation like we're going to write log from the left and from the right side of the equation. And after that, based on the power rule, the equation may be written in the form of log 4.2 is equal to this equation. I think that's too long to pronounce it, so you can pretty much see that. And what we can do now, I suggest to move. Excuse me, please. I didn't expect that. I'm sorry. So based on this equation, what I wanted to say, I highly suggest to move the part with x to the left side, and we may move log 4.2 to the right side. So we're going to get an equation: 1 minus 0.13 multiplied by x is equal to log 4.2 divided by log 10. And since there is no base written, we know that it is equal to 10. So that's like 10 is going to be like log 10, 4.2, log 10, 10, right? So we're going to find out these logs using calculator, and we have got an amount of 0.623 divided by 1. So that's basically just 0.623. And in this case, that's pretty simple to find out the x variable, and we're going to do these simple steps. We're going to move 1 to the right side. After that, we are going to divide the amount which we have got by 0.13, and x is going to be equal to 9.9 meters. So answer for part 1 in this case, at the depth of 2.9 meters, plants will receive the appropriate light. And let's have a look at our graph. As you can see, I've added one more line, and there is a point where it is going to intercept our like basic the graph for the basic equation, and that's like 2.9 and 4.2, and this is what we're going to have right now. But now we need to go to the second question, and let's have a look. Since it was written that we need to go 5 more meters down, it means that that's basically 2.9 plus 5 meters. That's going to be 7.9. And let's have a look. So D1 is for depth 1. That's going to be 2.9 meters, and depth 2 is for like D2 for depth 2, 7.9 meters. So we kind of need to get a simple equation. We're going to take the first light intensity and the second light intensity to find out how much one is bigger or less than the other one. We just need to divide them. So we're going to divide the first one over the second one, and we're going to get this nice equation. Again, too long to read, but let's do that. 10 in the power of 1 minus 0.13 multiplied by 2.9 I meant, and divided by 10 in the power of 1 minus 0.13 multiplied by 7.9. So we're going to get these nice equations. So that's going to be 4.198 divided by 0.940. What did I say? Let's just do that once again. I'm not sure that I've said it correctly. 4.198 divided by 940. Yeah, I'm really sorry for that one. So that's going to be 4.466 times less intense. So let's go ahead for our part 2 answer. That's going to be 4.466 times less intense is the light received by the plants if they were to be placed in water 5 meters deep than the point where they received a sufficient amount of light. Again, nice picture, just not to make it look boring. And we have the second additional line, and the point of interception is 7.9 and 0.94. I've added this line, and this is our final graph. That's what we have got, and you can see how much it has changed within those 5 meters. Thank you very much. Thank you for your attention. Hopefully you have understood it correctly. Hopefully I've explained it correctly. Thank you so much. Have a nice day.